Hello everyone, this is Liao. This is homework 11, the stochastic process. I wanted to record the first question. The first question is about the sta a stochastic process, which is white and stationary, and I wanted to find the property of autocorrelation function and its spectrum. First, I should prove the autocorrelation function is real and even, and then I have to prove the spectrum is even and non-negative. So look at it. First, I want to write down the basic definition of autocorrelation function, like this. Here, actually, I put in minus tau as a replacement of tau because I can set any value of the tau. So here I said the minus tau is equal to tau. So this is a basic definition, and then I have to say, because of the stochastic process xt is white and stationary, that means if I shift any time, I can get the same autocorrelation function. But this is under the condition of the duration of two times. The differences of two times is the same, hold the same thing. So here I wanted to shift tau. I shift the time to shift time tau. Here I wanted to say I got the answer. This is an answer after shift, and I find it is exactly the autocorrelation function of tau. So I see I can find the Rx minus tau equals to Rx tau. So autocorrelation function is even. And then I have to say, actually it is real as well, because imagine here, autocorrelation function is got by finding the expected value of two random variables. Here, by the basic definition, we have to see it is got by finding the expected value of xt and xt minus tau, right? And because of xt is always real, that means the two guys are real. So the expected value should be and must be real. So I got a proof. Then I had to find the spectrum is even and non-negative. Here, first I have to see the autocorrelation function. I use the Fourier transform. Here I got this formula, and actually this formula, the tau, I give a number. I give tau equals to 0, right? Why do this? Because this guy have another meaning. That means first I should write down the autocorrelation function. This guy is equal to, I use a basic definition of autocorrelation function. I find it is this, that it has a meaning, means the energy. So the energy should be and must be non-negative, right? Then please think about a system. The system like this. This is a system. Only when W equals to W0, the signal can pass or cannot. So here I write down the autocorrelation function that I used before is equal to this guy, right? And this guy, because is y means output, and I wanted to use input and the system to show the output. So I write down like this. Finally, we got the answer like this. As I said before, it is non-negative, so it is larger than 0. Actually, W0 can be any value. So the spectrum is non-negative. I got proved. In terms of the even property, we have lots of ways to prove it, but here I want to use a basic definition because the autocorrelation function, after it do the Fourier transform, we got a spectrum. Here, the basic definition, if we set minus W here, we got, this is a basic formula. And then I wanted to replace tau with minus tau. So all the tau here becomes to minus tau. Minus tau, minus tau, minus tau, and as a range as well should make a change. So I write down this guy. And then I have to use the even property of the autocorrelation function. So the two guys are same. And then I find it exactly the spectrum of W. So they are even. They are the same, so the spectrum is even. So by the way, the autocorrelation, the spectrum is always real. Why? Because the spectrum, I put in the conjunction, and we look what exactly do. Here, by the basic definition, we'll find we can put the conjunction into the brackets like this, and because it is the even function, and then we write it down like this, and finally we got the answer, and it exactly like this. So we got proof. That's all.